Sometimes we factor polynomials that we consider a special case. Today we're going to talk about two of these cases, and the first special case is called the difference of perfect squares. For this example, we are literally finding the difference or subtracting two perfect squares. And to factor this, what you're going to do is take the square root of each term, and then you're going to rewrite it as the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So each binomial is going to be the same except for the sign that's in the middle. So you got to make sure the signs are different. Let's do a few examples here. So example 1, 2, and 3, I know they are the difference of perfect squares because each of the first terms is a perfect square, and each of the constants is also a perfect square. So let's start with example 1. The square root of x squared is x, and the square root of 64 is 8. So when we rewrite this, it's going to be two binomials. X is your first term in each, 8 is your second term in each, and you're going to switch up the signs, so plus and minus. You could have easily done minus and plus. That order doesn't matter. What matters is that the signs are different. Okay, same in example number 2. We have the first term now, but now this term has a coefficient. That's fine because that is also a perfect square. So the square root of 16x squared, well, the square root of 16 is 4, and the square root of x squared is x. So we're going to get 4x, and the square root of 121 is 11. So same thing, two sets of parentheses. The square root of the first term is 4x. The square root of the second term is 11. We're going to switch up the signs, plus and minus. Okay, last example. Now we have 4x to the fourth power. 4x to the fourth. The square root of 4 is 2. And we know that a variable with an exponent is a perfect square if the exponent is even. So it does have to be even. And then to find the square root, we're just going to take half of it. And if you're wondering why this is true, if you remember your laws of exponents, x squared times x squared, these two are the same, right? We get x to the 2 plus 2, which is x to the fourth. That's going to be the same with any exponent that's even. So let's say it was like, I don't know, x to the 60th power. Well, that would be x to the 30 times x to the 30, because that's equal to x to 30 plus 30. So essentially, the rule here is if the exponent is even, it's a perfect square, and the square root is half the exponent. And the square root of the second term, 225, is 15. So again, set up your parentheses. First term is 2x squared. Second term is 15. And switch up your signs. Now, one thing to just make sure and double check before you're doing questions like this is to remember that this is called the difference. It's not popping up right now. Whoa. This is the difference of perfect squares, and it's still not popping up. Oh my goodness. You guys see this craziness? It's the difference of perfect squares, meaning that this needs to be a minus sign. Had this been x squared plus 49, we cannot factor that because it's not the difference of perfect squares. Okay, let's move on to the second special case. This is called a perfect square trinomial. And this is going to be when the trinomial has, so it's constant. So this here, its constant is a perfect square. And its linear coefficient is double the square root of the constant. Okay, so what do I mean by that? Well, the square root of 25 is 5, and half of 10 is 5. These two numbers must be the same. And if that is true, then it's a perfect square trinomial. And to factor, we're going to find the square root of c. We're going to find half the linear coefficient. We're going to make sure those numbers are the same. And then we're going to rewrite it like you see in this example below. And we're going to make sure that we keep this sign. So this sign here has to stay the same, which means we can rewrite it as the binomial squared. Okay, but let's do a few examples. So let's do example number 1. Okay, so we see that the constant is a perfect square, and the square root of 64 is 8. And the linear coefficient is 8. Half the linear coefficient, so 8 divided by 2 is 4. And these numbers do not match, which means this is not a perfect square trinomial. So what number would this linear coefficient had to be to make it a perfect square trinomial? It would have had to be 16. And this is actually a typo. I meant for this to be an actual correct example. So I'm going to go ahead real quick and pretend like this is a 16. Because now half of 16 is 8. These two terms match, so we can move ahead. Which means we're going to rewrite this as two binomials. We got x in the front of both this time. This number here that matches is 8. And we're going to keep this sign. So this minus sign, we get minus 8, minus 8. And we can rewrite this as x minus 8 squared. Okay, let's do a couple more examples, and hopefully I didn't make the typos there. I think I made it in 3 already. I see it. Okay, so example number 2. C is a perfect square, and the square root of 121 is 11. We take our middle term, which is 22. Half of 22, so 22 divided by 2, is also 11. So boom, these two terms match. So this is a perfect square trinomial. So we're going to set it up again. X is the first term. And these two numbers here are 11 and 11. We keep our sign, which is a plus right here. So this is x plus 11 times x plus 11. So we get x plus 11 squared. Okay, that's example number 2. We're going to move on to the last example. So we have x squared minus 15x plus 225. The constant is 225. The square root of 225 is 15. Our linear coefficient is negative 15. We're just going to take the 15. 15 divided by 2 is 7.5. And these numbers are not equal, which means this is not a perfect square trinomial. This b term instead, this number here would have to instead be 30. Because then you would get 30 divided by 2, which is 15. And now these numbers are equal. So we can rewrite this. Here's our two binomials. We got x and x. These two numbers that are equal are 15. We keep this sign here, which was a minus. And we get minus 15, which we can rewrite as x minus 15 squared. And if you are not sure if your answer is right, please always do the reverse and multiply them out, either using the area, distribution, or the FOIL methods. So let's go ahead and check if one of our answers are right. I'm going to check our answer for number 2, since it was the only one I didn't make a typo in. So if we FOIL out x plus 11 times x plus 11, we should get x squared plus 22x plus 121. So let's check it out. So in FOIL, we got f, which is the first. X times x is x squared. We got O, which is the outside. So we got x times 11, which is 11x. We got the inside for I, which is 11 times x, which is 11x. And we got the last for L, which is 11 times 11, which is 121. Here, these are like terms, 11x and 11x, we get 22x. And when you take all of the terms, we got x squared plus 22x plus 121. And that is a perfect square trinomial. Let's go ahead and also check on a difference of perfect squares. I'm going to do example 3 for this one. So if we multiply out 2x squared plus 15 times 2x squared minus 15, we should get 4x to the 4th minus 225. And let's test that out. For f, we're going to do 2x squared times 2x squared. Well, 2 times 2 is 4, and x squared times x squared, if you do 2 plus 2, you get x to the 4th. All right, now O, it's the outside. So you get 2x squared times negative 15. Negative 15 times 2 is negative 30, and you have x squared. Now we have the inside, which is 15 times 2x squared. 15 times 2 is 30x squared. And now L is last. You do 15 times negative 15, which equals negative 225. And we see we have like terms of the two middle terms again, negative 30x squared plus 30x squared. These terms are actually going to cancel out. You get 0x squared. It's negative 30 plus 30 is 0. But we don't need to include that since the coefficient is 0. Instead, we're just going to get 4x squared minus 225. And this is why it's so important, this minus sign, why this must be subtraction. Okay, so I hope this was helpful. Email me with questions.